Okay, so we've given a derivative function and we need to sketch it. So we'll pull up our graphing calculator. We'll add a graph page, type in the function. We've got x to the power of 3 minus 16x. We can see where the graph crosses the x-axis here, but we can't see the maximum points, and we would like to see the whole function. So I can see that let's find first the zeros. So we'll analyze the graph. We'll find the 0 here. Then we'll repeat the process for the other two. Okay, we've got our 3 zeros here now, but we can't see the maximum and minimums of this graph to sketch it properly. So halfway between those sets of roots is the value 2. I'm just going to pop over here, pull up the function, find out what the value is when x equals 2, do the same for what the value is when x is equal to minus 2. I see it's going to go up to about 24 and down to about minus 24. So when I come to the window settings, I can just adjust my window settings now to exceed those values slightly. I'll choose minus 30 and 30. This isn't enough, I'll re-sketch, but that looks good. So to answer the first question, need a little sketch. It'll look like this. Graph looks like that. What's important to label here are those points. So minus 4, 0, 0, 0, and 4, 0. So your axes intercepts are typically important points that you should include in your sketch. We've got, this is x-axis, this is y, and this is y is equal to f dash of x, f prime of x. So we've got our derivative. That's A. Write down the intervals when the function is increasing. So what's interesting for us here is where it changes from positive to negative. So I'm just going to put in a couple of lines. I'm going to put in a line there. I'm going to put in a line there. I'm going to put in a line here. So this curve is going to be positive here. And it's also positive here, onwards to infinity. This curve is going to be negative here. And it's also negative here to negative infinity. So we need to describe these intervals. So we can use either inequalities or interval notation. So let's start off with rising. It is going to be rising in that interval. That would be minus 4 up to 0. Or x is greater than 4. So that's second interval here. It is falling, and I'll do this one using interval notation. It's going to be from negative infinity up to negative 4. And then it's going to have another interval from 0 up to 4. So you could use either of these two styles of notation to explain the interval where it's rising and falling. So the second one is, so this is where it's falling, and this is where it's rising. We need to describe those intervals. Which values does it have a local maximum? Which values does it have a local minimum?
Wait, so can you write the following the way that you were rising if the negative is smaller than x?
This one? Yeah. So this could be written as x is less than negative infinity, less than negative 4, or x is between 0 and 4. So we could write it like that. So for C, we need to identify the local maximum and the local minimum. So a maximum has this pattern. It goes up, it goes 0, and then negative. A minimum has this pattern. It goes 0, it goes negative, and then it goes positive. So which at x equal to -4, does the graph go positive, 0, negative, or negative, 0, positive?
Negative 0 positive.
It goes negative, 0, positive.
So it's
It goes negative, 0, positive. So at x equal to -4, or it also does it here, at x equal to 4. If we notice, however, here at 0, it goes positive, 0, negative. Positive, 0, negative. So this is at x equal to 0. We have a maximum point at x equal to 0. We have a minimum point at -4 and 4. Are any of these global extreme points? No, they're not going to be. We can see clearly that here in this region, the graph will continue, the derivative will get larger and larger positive values, which means the graph will continue to rise. The original function just keeps rising here. Here in this direction, the derivative just keeps getting more and more negative, which means the original function just keeps going down more and more and more. So for D, no. The graph will keep rising toward infinity and falling toward negative infinity.
So if there wasn't enough time, then there would be a local extreme.
If the curve has a limited domain,
Yeah.
we couldn't really tell from the derivative, but it could have these could be global maxima. But for this question, the best way of there being a global maximum is if the derivative started positive and ended positive, meaning there's some point where it's at its largest negative value, and that would make it stop.
Okay. So basically, when there's no equals, right?
No, I think for this question, in the structuring of this question, I think it's when both of them have the same infinity, both positive or both negative. Then you would have you would have a global maximum somewhere, or a global minimum.